Okay, this one is all about writing a function rule. This one's all about how do you write a function rule. Now, a function rule is just like an equation that you need. So it's important to pay. It's not super tough. It just takes a little practice. But writing a function rule. So there's a few things that you got to understand. Is that a lot of real world stuff. This comes up. All right, so you just got to think about, what you're dealing with. So I'll walk you through this first problem. Um, Insects, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than one fourth the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? Oh wait, there's a couple things in here that I see. All right, 40 degrees more than the one fourth number of chirps in a minute. What's the function rule that represents the situation? So I guess temperature is a function of the time or the number of chirps. So I'm going to say T is equal to, and then I'm going to say, all right, it's 40 degrees more than. So 40 degrees more than one fourth the number of chirps. Well, I'm going to write one fourth and then the number of chirps. Boom, done. It's literally that simple. Okay. Now, when I'm looking at this, this is actually a linear. Um, this is actually a linear function, so you can easily make a graph of that. Looking at a little more challenging one, you're looking at write and evaluate a function rule for a concert seating plan is shown below. Reserved seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? Now, look at this picture. This looks kind of like it's like Pine Knob. Or you don't call it Pine Knob anymore, we call it DTE. It's like DTE. The green general seating is like the hill, and the reserve seating is like the pavilion. So it says that the reserve seating is $25, 10 rows, 12 seats per row. General seating is $10. There are 30 rows, 16 seats per row. Now, there's a couple things that you have to think about. It says that the reserve seating is already sold out. So we could actually do a little math and get a total number, how much revenue we got from this. So if there's 10 seats, 12 rows, $25 a ticket, let's multiply all three of those together. 10 times 12 times 25, right? That gives me the total revenue that I get from that. So 10 times 12 times 25, that comes up to be 3,000. So I already know that my revenue R is going to be $3,000 plus. Plus what? I don't know. Well, I do know that my general seating is 10 bucks, right? A ticket. Boom, that's it. 10 times N. However many general seating tickets I sell, multiply it by 10, add it to 3,000. There's my revenue for my stuff. Now, it says, uh, what is the maximum possible total revenue? Well, that seems pretty easy to figure out. Here's that. The maximum possible revenue is to capacitize this stadium. So 30 times 16. What's 30 times 16? 30 times 16. 30 times 16, I believe, is 480. So then what I can do is I can take that 480 and I can plug it in to the number of tickets that I sold. And when I multiply 10, so that's 3,000 plus 4,800, that gives me $7,800 is the total revenue that I'm going to have. So you got it. Pause the video, do it. I'll see you back here in a minute. We're going to look at nonlinear stuff. So write a function rule. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle with the width of 90 feet, or 90 feet, 9 feet? So with this one, the first thing I'm going to do is I'm going to say rectangle is important. Length is 5 feet more than its width. So I'm going to, and then it says area. So I'm going to draw a rectangle. All right. And if I call this x, this is 5 plus x. Agreed? If that's x, I'm going to call that 5 plus x, or x plus 5, either way. I'll call it x plus 5. Let's call it x plus 5 to be nice. And area is L times W, but we're going to call area is going to be equal to x times x plus 5. Now if I do this, area is x squared plus 5x, and then it says find out what the area of the rectangle is when its width is 9 feet. When its width is 9 feet. All right, so I guess I plug 9 in, so I find a of 9. So I plug 9 in to this problem. 9 times 9 squared is 81. So this is 81 plus 45. So the area I have is 81 plus 45, which is 126 square feet. 126 square feet. So that wasn't too bad, was it? I think it was pretty easy. You ever got it? Do it. So function notation. Function notation was that f of x junk that we talked about a couple days ago. Function rule, that's just an equation. So if you know those, check those off. Okay, function notation would be the f of x or the a of x or any of that stuff. So make sure you know how to do that. And again, that was a pretty simple lesson. I look forward to seeing you in class, and may the force be with you.